Okay, question 5. You can look at this equation here and see, well, two things really. The question is talking about turning points, so you can be pretty sure you're going to need to put dy by dx equals 0 at some point. And this bit here is a function of x times by another function of x. So to differentiate, you're going to need to use the product rule like we did in question 3. So let's get on with it then. We've got y equals x squared e to the minus x. As I said before, when you use the product rule, it doesn't matter which is u and which is v. Whoops. V. And I like to write this out at the side. So du by dx is 2x. V equals e to the minus x. And dv by dx equals minus e to the minus x. So now we can use the product rule, which is u dv by dx plus v du by dx. Stick all the values in, and that's x squared times by dv by dx, which is minus e to the minus x, plus v, which is e to the minus x, times du by dx, which is 2x. So if we just tidy all that up a bit, actually we could probably just factorize that maybe. Now let's just expand it. So let's do that's minus x squared e to the minus x, and that's plus 2x e to the minus x. So you can see this will factorize, because we could take out an x and an e to the x from everything. So let's just do that. If we take out x e to the minus x from everything, we're going to be left with a minus x plus 2, which is the same as 2 minus x. If you wanted to check that, you could just do, if you multiplied that by 2, you would get this. If you multiplied this by minus x, you would get this. Now that's going to be helpful when it comes to solving this equal to 0, because at the turning points, dy by dx equals 0. So that means we now have 0 equals x e to the minus x 2 minus x. Now if you look at this, e to the minus x can't equal 0, e to the anything can't equal 0. Let's just make a note of that. Can't equal 0. So therefore either x equals 0 or x equals 2, because we either need this to equal 0 or this to equal 0, just like when you're solving a quadratic. And if x equals 0, when x equals 0, we can substitute that back into the original equation, and we'll get y equals 0. And when x equals 2, we can substitute that back into the original equation, and we'll get 4e to the minus 2. The question asks for coordinates, so we should really finish that off by writing the final answer in coordinates, which are 0, 0, and you'll also have a stationary point at 2, 4, e to the minus 2. So that's the final answer for question 5. You have those two stationary points, turning points, where dy by dx equals 0. Question 6, this is a classic implicit differentiation question. Implicit differentiation. How do you know you need to use implicit differentiation for this? Well, you might just recognize the form of the equation from doing practice papers or from exercises in the book. But as a general rule, if you look at this, you're going to really struggle to get y on its own here. Usually when you differentiate, if you look at question 5, you've got y on its own, or you can rearrange it to get the equation to get y on its own. But you're really going to struggle to get y on its own in question 6. So that means you are almost certainly going to need to use implicit differentiation if you're asked to find whether curve equals dy by dx. So let's do implicit differentiation then. Excuse me, I'll just write down the equation first of all. X squared plus 2xy minus 3 y squared plus 16 equals 0. Let's do the things that are easy to differentiate first. X squared will differentiate to give 2x. We're differentiating everything with respect to x, by the way. So differentiate x squared, we get 2x. Very straightforward. I'm going to come back for that because that's a bit more awkward. You need to use the product rule for that. If you differentiate minus 3y squared, you differentiate with respect to y first of all, so that will give you minus 6y. But then you just stick a dy by dx down. When you differentiate 16, you just get 0. When you differentiate 0, you just get 0. So let's go back to this bit here, the 2xy, because to differentiate that, you need to use the product rule. Okay, so let's do that. Let's do that over here. Let's do the product rule over here. We want to differentiate. Let's just make a bit of a gap. We want to differentiate 2xy with respect to x. So let's let 2x equal u, let y equal v, and then when you differentiate, well, let's just write this out first. So u is 2x, so du by dx is 2, v is y. Now when you differentiate v, when you do dv by dx, you differentiate y with respect to y, you get a 1, but then you stick a dy by dx down. Okay, so let's now stick that into the product rule. U dv by dx plus v du by dx, and that will give us 2x. Dv by dx is this, which is dy by dx, and then we've got to add y. Du by dx is 2, so that's just going to give us a 2y. So all of that here needs to go here. Okay, so let's move that all over to here. So we'll get plus 2x dy by dx plus 2y. Okay, so we've now differentiated everything with respect to x. Let me just make a note that this all went over to here. So we now differentiated everything. What we want to do now is to get dy by dx on its own, and then we can find out what the coordinates would be where dy by dx equals 0. So let's just get dy by dx on its own then. If you look at this, we can get all the dy by dx terms on the left hand side. So that's 2x dy by dx minus 6y dy by dx, and actually it might be easier put things on the other side, I'm just thinking it might be better just to leave these as being positive. So actually scrap that. Let's put the dy by dx on the other side. So we've got 2x plus 2y. It doesn't really matter, but let's put the dy by dx is on the other side. And then we've got 2x dy by dx. If we factorize now to take the dy by dx out, we'll have dy by dx times by 6y minus 2x. So if we divide this by this, we'll get dy by dx on its own. So dy by dx is going to equal 2x plus 2y all over 6y minus 2x. Okay, so now we need to solve that equal to 0. Let's just clear a bit of space on the right hand side over here. Okay, so let's move that over there now. It tells us in the question that we want dy by dx equals 0. So now if we put 0 equals 2x plus 2y over 6y minus 2x. Now often students forget that if you're trying to solve this equation now, this denominator can never equal 0, so you don't really need to worry about it. The only way this fraction on the right hand side is ever going to equal 0 is if the numerator equals 0. Okay, so all you need to write down, you can ignore the denominator and just write down 0 equals 2x plus 2y, and then what you have is, well, it's just 0 equals x plus y, so you can rearrange that to get y on its own. Now if you substitute that back, this all the way back into the original equation, if we put this all the way back into our original equation here, we will have an equation just with x's in, which we should be able to solve once we've done that. So let's put that back into the original equation. We're going to get x squared plus 2x times y, which is going to give us, well, I'll just stick a minus x there for now. And then we've got minus 3y squared, which is minus 3x squared plus 16 equals 0. And obviously this middle bit here, this middle bit is the same as minus 2x squared. Okay, so we've got a lot of x squareds there that we can collect together. What will this become? This will become minus 4x squared plus 16 equals 0. So x squared will equal 4. So x will equal plus or minus 2. If x is, it says coordinates, so we should give the final answer as coordinates. If x is 2, when you substitute that back into here, so if x equals 2, you just put it back into here, and you will get y is minus 2. In a similar way, when x is minus 2, you can just substitute minus 2 back into here, and that will tell you that y is plus 2. So those are the coordinates where dy by dx equals 0.